Hello, it's day 3 of our three-part unit on waves. Day 1, we looked at waves in the general sense, what is a wave? Day 2, we looked at the properties of wave, and here we are on day 3, how do waves interact? What are the interactions that occur between waves? So let's jump in today. Hope everybody's doing okay. I enjoyed reading your superhero names for our attendance recording yesterday. I'm still debating on what my superhero name would be. Wonder if you guys have any ideas. All right, so as we look here at waves, let's go ahead and talk about some of their interactions. The first interaction we want to look at is reflection. And we got to see this when we were in class, and we put the mirrors up to the star that was in that Learn Ed notebook. And we noticed that the reflection is then, after it hits the barrier of the mirror, it reflects the waves back. So reflection, waves reflect after hitting a barrier. All waves can actually be reflected, and waves can also be transmitted through a substance. So the basic definition here that we're going to look at for reflection is this happens when a wave bounces back after hitting a barrier. And so the first interaction of waves is a reflection. Here's a nice picture here. The angle of light hits the mirror. It then bounces off the barrier, which is the mirror, and reflects. So reflection is our first type. The second wave interaction we're going to look at today is refraction. This is the bending of a wave as the wave passes from one medium to another at an angle. So here's our medium, this liquid here. The light wave passes through it, and then we can see a little refraction. We see that light wave begin to bend as it passes through that medium. We should have been able to see some refraction if you were in one of the groups that did the lab with the water and the penny. We can also see refraction here as we look with how the straw appears to look in the water as we look through it as that wave bends in the water. So this is the angle of incident. This is where the wave is hitting. And then the angle of refraction is what we actually see as it goes through the wave. Diffraction is another interaction. This is the bending of a wave around a barrier or through an opening. We refer to that as diffraction. We see right here with our water, the barrier are these blocks of sand. The water then either goes through the opening or it refracts and goes around. Again, here it is, boom, 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 boom. It hits this barrier, so then it diffracts and comes through, not refracts, but diffracts and comes through. We saw this with the block that we had in the pie pan. We put the water in the pie pan, we had the block then in it, and then once we created a wave with our pencil tip, once it got to the block, it simply just went around that block and created the wave on the sides and then to the back. And so we refer to the bending of wave around the barrier or through an opening that's there as diffraction. Interference, this happens when waves overlap. So it's constructive or amplitude increases. So if we have interference, the amplitude of the wave, if it's constructive, it increases, okay? So if it's right here, sorry about that. So if it's constructive, the amplitude increases. If it's a destructive interference, the amplitude decreases, okay? And so we see less amplitude here because, again, amplitude is how from the crest to the rest. We see that as the amplitude. And so here we see in the constructive wave, the amplitude increases. In a destructive interference, the amplitude, let's back up. In the constructive, the amplitude increases. In a destructive, the amplitude is decreased. Destructive, decreased. Constructive, increase. You can see that as the pictures. Hope I didn't confuse you there. So here it is again. Interference happens when the waves overlap. If those waves overlap and then the amplitude dies out, that's destructive. It lessens, it decreases, it weakens. If they hit each other and it increases, we have larger waves, the amplitude increases, then that's a constructive interference. Resonance, we could hear this. This is a vibration produced in one object that's caused by the vibration produced in another. So if you've ever hit like a spoon on the side of a glass with water in it, that's resonance. You can hear those sound waves vibrate, and it causes the vibration to then be produced from the spoon to the cup, throughout the cup, and into the air so that we can hear it. So this is resonance. It's when a vibration is produced in one object that causes the vibration produced in another. So if we were to complete this chart, so if you're at home, feel free to draw this out. And then we're just going to write, what do we know about our properties of waves here? What are some of our properties? If you remember that from the day before, things like amplitude, wavelength, wave speed. So we list the properties here. So as you're drawing this out at home, you're going to list the properties. Please refer back to the day 2 notes or the day 1 notes as well. When we look at what they can undergo, we look at that waves. These are their, again, we refer to these as their interactions. They can undergo reflection. They can also undergo interference. These are examples. Do you remember what type of waves these are? Oh, you guys are awesome. You were quick. Correct. These are electromagnetic waves. If we come over to these types of waves and we look at these waves, what can we refer to those as? That is correct. These are mechanical waves. Electromagnetic waves do not need a medium. Very good. They do not need a medium. Mechanical waves need a medium. Again, a medium is a material or the matter through which to pass through. Electromagnetic waves are always, what goes here? Great job, mechanical waves. Mechanical waves can be either, got to go back. We made a mistake, didn't we? Electromagnetic waves do not need a medium. They are always transverse, not mechanical. That should say transverse waves. Mechanical waves need a medium and can be either transverse or longitudinal. Did you get all that? If not, let's check the next screen here and check our answers. There we go. All right, and so make sure on your sheet there that you are filling in this chart. Draw this chart out if you have your science notebook with you or on a piece of notebook paper, just so that you have this information and this becomes as an overview and study guide for what we've written down on waves. I do believe coming up on Monday you have a short quiz on this, and so you can use this sheet as a guide. So take a few minutes to process your learning. Again, write this down either in your interactive science notebook if you have your composition notebook with you. If not, you can write it in the back of your Learn Ed notebook, or you can simply draw this chart out on paper so that you can use it as a guide to assist you with testing. Hope everybody's having a great day. I'll be back in touch for future lessons. This concludes our waves part 1 through 3. Feel free to go back and check the other videos if you just need a reference, and keep doing great things. Talk with you soon. Enjoy the rest of your day.